So I'll talk about the synthesis of thyroid hormone. So basically, we have thyroid gland below the level of larynx and in front of trachea. In front of trachea. We all know the basic functional unit of a brain is a neuron, and the basic functional unit of a kidney is a nephron. So what is the basic functional unit of a thyroid gland? It is something called as follicle. It is something called as follicle. But what is a follicle? A follicle is lined by a single layer of simple cuboidal epithelial cell, and in its center it contains colloid. In its center it contains colloid. So thyroid gland basically is made up of this follicle throughout. This follicle throughout. So thyroid gland is ductless. It does not contain any ducts. So all these hormones get secreted directly into the blood, directly into this blood. So thyroid is basically as rich blood supply. So in between these thyroid follicles, you have so much of blood vessel running around. And we have another important cell called as parafollicular cell that is present beside this follicle. And this secretes out calcitonin. This secretes out calcitonin. So you can see the same in this image as well. This is a single follicle and it is lined by simple cuboidal epithelial cell. This single epithelial cell is called as follicular cell. Follicular cell. So here you can see this is a single follicular epithelium. The side that is facing towards the capillary is basal membrane, and the side that is facing towards the colloid is called as apical membrane. So you can see the same in this image as well. You take a piece of thyroid, and if you look it up under the microscope, you'll see this image. So this is single follicle lined by follicular epithelium, and in its lumen, it contains colloid. This is the another follicle, this is another follicle, and in between these follicles we can see capillaries. And then I talked about C cell or parafollicular cell that secretes calcitonin. So this is the actual image. This is the actual image of a follicle. This is the single follicle, and the cells which are stained with violet color is follicular epithelial cell, and inside and in the lumen you can see colloid. In the lumen you can see colloid. So that is the basic histology about the thyroid gland. So for the synthesis of thyroid hormone, what do you need? You need two important raw materials. For the synthesis of thyroid hormone, you need two important raw material. One is thyroglobulin. One is thyroglobulin. And the second important raw material is iodine. Second important raw material is iodine. So I'll talk about thyroglobulin first. So what exactly is this thyroglobulin? What exactly is this thyroglobulin? The thyroglobulin is basically a glycoprotein, but majorly it contains protein. And which protein? It contains tyrosine amino acid. It contains tyrosine amino acid, and approximately it contains about 70 tyrosine amino acid. So in this image, you can see this is the structure of the thyroglobulin, and mostly you can see tyrosine is present. Mostly you can see tyrosine is present, and other substrates as well. Other substrates as well. So this thyroglobulin, where is it getting produced? Where is it getting produced? This thyroglobulin is produced by the follicular epithelial cell. This thyroglobulin is getting produced by the follicular epithelial cell. The thyroglobulin, which was produced inside the follicular epithelium, gets across the apical membrane and gets dumped in the colloid. Gets dumped in the colloid. So all this follicular epithelial cell actively secretes out all this follicular epithelial cell actively secretes out thyroglobulin in its lumen, and basically that becomes your colloid. Basically that becomes your colloid. So colloid is nothing but a glycoprotein aggregate called as thyroglobulin. Called as thyroglobulin. So who is influencing or who is signaling for this thyroglobulin production? For this thyroglobulin production. So basically, thyroid stimulating hormone TSH is signaling for this thyroglobulin production. So in this image, you can see from the circulation, TSH is acting on TSH receptor, And so many steps happen after this. I'm not going to talk about that. Ultimately, through DNA transcription and translation, thyroglobulin gets produced. Thyroglobulin gets produced. The thyroglobulin, which gets produced inside the follicular epithelium, gets across the apical membrane to enter into the follicular lumen. So the next important raw material that we need is iodine. But unlike thyroglobulin, which was produced by the follicular epithelium, we get iodine from our daily diet. Iodine is fortified with salt. So through diet we get iodine. Eventually it ends up in the thyroid gland. It enters the capillary. It enters the capillary. Basically, iodine has to eventually enter the luminal cell. The luminal cell. From the capillary side, it needs to get across to enter into the luminal cell. So how is this happening? So this is where iodide is present. So with the help of sodium iodide importer, it gets into the follicular epithelium. So where are we getting this sodium from? So we are getting this sodium from sodium potassium ATPase pump, which secretes out sodium outside and puts the potassium inside. So this sodium comes here and gets inside the follicular epithelium. So when it gets inside the follicular epithelium, iodide also gets transported across into the follicular epithelium. That is called as symporter, sodium iodide symporter. So through this importer, iodide gets accumulated inside the follicular epithelium. So this process of getting iodide inside this follicular epithelium is called as iodide trapping. Iodide trapping. So we are trapping so much of iodide inside the follicular epithelium. So the iodide which is present inside the follicular epithelium needs to get across the apical membrane into the luminal cell. So in the apical membrane side, we have a special channel called as pendrin, which puts chloride into the follicular epithelium and secretes out iodide into the luminal cell. Iodide into the luminal cell. So, so iodide trapping is the first process. The next process is called as oxidation of iodide ion. Oxidation of iodide ion. So this is the apical membrane. This is the apical membrane. This is the apical membrane. This is the pendant. This is the pendant. You can see chlorine is getting inside, iodide is getting across, and then entering into the luminal cell. Here you can see iodide is negatively charged, but once it gets across the apical membrane, it becomes iodine. This form is iodine. The negatively charged form is called as iodide. So process where the iodide basically loses its negative ion is called as oxidation. Oxidation is basically loss of electron. So this is what I've written here as well. Iodide loses its negative electron, becomes iodine. So who is doing this process? This is done with the help of an enzyme called as peroxidase along with hydrogen peroxide. Along with hydrogen peroxide. So after oxidation, the next step is iodination. The next step is iodination. Now we have iodine in the luminal side, and we also have thyroglobulin in the luminal side. So this is thyroglobulin. This is the luminal side. This is thyroglobulin. Now we have iodine. As I told you, thyroglobulin have so much of tyrosine residues. So what is iodination? The process where this iodine gets attached to the tyrosine residue is called as iodination. When one iodine gets attached to the tyrosine residue, we call it as monoiodotyrosine. Monoiodotyrosine. When two iodine gets attached to the tyrosine residue, we call it as diiodotyrosine. We call it as diiodotyrosine. So this is all about iodination. So the next step is called as coupling. So we have monoiodotyrosine here, we have diiodotyrosine here. When diiodotyrosine combines combines with monoiodotyrosine, it becomes T3. It becomes T3, triiodothyronine. And when one DIT couples with another DIT couples with another DIT, it becomes T4, tetraiodothyronine. So this process of coupling MIT and DIT And D80 and D80 together is called as coupling. Is called as coupling. So far we have seen oxidation, and then followed by we had iodination, and followed by we had coupling. All these three process is done by a single enzyme called as thyroid peroxidase. The final step is secretion. The final step is secretion. I would like to show all these processes in a single image. So you can see in this image, sodium, through sodium potassium ATPase pumps, sodium comes outside, and here through the sodium iodide importer, sodium gets inside. When sodium gets inside, along with that, iodide gets inside the follicular epithelium. This process is called as iodide trapping. Iodide trapping. So this iodide gets across the apical membrane into the lumen by through pendrin. So when it is going through this apical membrane with the help of thyroid peroxidase enzyme, iodide gets converted into iodine. This process is called as oxidation. This process is called as oxidation. Once oxidation happens, the next step is iodination, and followed by iodination, we have coupling. Ultimately, we have thyroglobulin that contains T3, T4, MIT, DIT. I'll talk about reverse T3 later. So what it basically means is, so this thyroglobulin that is present in the colloid that basically contains T3, T4. So let's say this is MIT, this is DIT, this is DIT. Not all MITs and DITs couples together to form T3 and T4. Some of them remain as such as MIT and DIT. So basically, thyroglobulin contains MIT, thyroglobulin contains DIT, T3 and T4 together. This is what is given. This is what is given in this image. This is what is given in this image. So this has to eventually get across the follicular epithelial cell and get into the capillaries. So this process is called as secretion. Through the process of pinocytosis, where your apical membrane changes its shape, and then it engulfs colloid droplet, it engulfs colloid droplet like this. Basically, this colloid droplet is acted upon by proteases. Basically, proteases breaks down thyroglobulin. So when you break down thyroglobulin, what will you get? When you break down thyroglobulin, what will you get? You'll get T3, you'll get T4, you'll get MIT, you'll get DIT, right? So this T3 and T4 gets across, enters your circulation. Whereas MIT and DAT does not get into the circulation, does not get into the circulation. So what does MIT mean? Tyrosine residue contains one iodine molecule. DAT means tyrosine residue contains two iodine, right? So when you cleave iodine from the tyrosine residue, that process is called as deiodination, and with the help of an enzyme called as deiodinase. This is what is happening finally. This is what is happening finally here. MIT and DIT, they undergo this process deiodination. So when it happens, tyrosine and iodine get separated. So as you can see, tyrosine and iodine gets separated, and iodine gets recycled. Iodine gets recycled. So that is all about secretion. In this image, you can see tyrosine. When one iodine is added, it becomes monoiodotyrosine. When two iodine is added, it becomes diiodotyrosine, right? So here you have T3, reverse T3, and T4. In T4, T4 basically means two DITs, right? Two DITs. This contains two iodine, this contains two iodine. So that is what we are seeing here. 1, 2, 3, 4 iodine. This is called as outer ring. This is called as inner ring. This is T4. When you remove one of the iodine from the outer ring of T4, from the outer ring of T4, it becomes T3. It becomes T3. So what basically T3 contains? One MIT, one DIT, right? This contains two iodine. This contains one iodine. So T3 has to have three iodine. So here T3, it has one iodine, two iodine, three iodine. This iodine is absent in the outer ring. So here iodine is absent in the outer ring. Similarly, if you observe reverse T3, if you observe reverse T3, one iodine, two iodine, three iodine is present. But here iodine is not, iodine is absent from the inner ring. Inner ring. So this is the difference between T3 and reverse T3. In T3, iodine is absent in the outer ring, and in reverse T3, iodine is absent in the inner ring. Iodine is absent in the inner ring. So what is the significance of T3? What is the significance of T3? You must understand most of the T4 which is produced in the body eventually gets converted into T3. Why is this happening? Because T3 is the one which is metabolically active. It can enter the cell, it can enter any cell and exert its action. Exert its action. It is biologically active. So imagine a person is in starvation or has severe illness. You don't want the body metabolism to go up, right? So you don't want the action of T3 here. Basically, thyroid hormone promotes metabolism. You don't want the action of T3 here. In case of starvation and illness, you want to promote as much as energy as possible. So in this case, when T4 loses one iodine from the inner ring, it becomes reverse T3. This reverse T3 which gets produced, it cannot enter the cell, it cannot exert its action. So that is why reverse T3s are produced. Reverse T3s are produced. In nutshell, I would like to say, in nutshell, I would like to say, for thyroid hormone synthesis, T3 and T4, you need thyroglobulin and iodine. You need thyroglobulin and iodine. And that is all you need to know about thyroid hormone synthesis. Thanks.